Welcome to the Equals Parent Training Series Part 2, Cause and Effect, Solving Everyday Problems. In this training, we will discuss ways that you can implement problem-solving strategies at home with everyday tasks. If you have any questions, please feel free to reach out to us in the Curriculum Department at curriculum@ablenetinc.com. Let's get started. Solving problems is a big part of math. It is important for students to know how the world works when solving problems in everyday life and when learning math. Students begin to make sense of different kinds of math problems when they begin to remember when I complete a specific action, a specific thing happens. For example, place a pile of 5 spoons on the table. Place a second pile of 8 spoons on the table nearby. Move the spoons together. When I move the 2 piles of spoons together, I have one bigger pile of spoons. This is what happens when we add. When we add 2 amounts, we have one larger amount. I could do the same with subtraction. Place a pile of 5 spoons on the table. Subtract 2 spoons and place in a second pile. When I separate one pile into 2 piles, there is a smaller amount, 3 and 2, in each pile. When we subtract, we have a smaller amount subtracted and a smaller amount left. This math knowledge provides students with information about the world. Students will be better able to make reasonable predictions or estimates when they solve different kinds of math problems because they have a better understanding of how math works in their world. In math, thinking about choices and what might happen supports students as they tackle problems and identify facts to make decisions about what to do, what tools to use, and what the outcomes might look like for each of those. Using objects, modeling actions, and providing choices helps students narrow the possibilities so they are better able to choose and act in a reasonable way rather than give up or feel overwhelmed. Here are examples of everyday problems you can solve with your child by providing objects to identify facts in the problem, model actions for the students to choose what to do, estimate or predict what the solution might look like, then choose a tool and a strategy or a plan to solve the problem. I'm setting the table. There are 5 placemats on the table, 1 for each person eating dinner. How many plates do I need? Identify the facts. Ask, what do I know? What are the facts? I'm making dinner, I'm setting the table, or there are 5 placemats on the table. Let me think. I'm setting the table, not making dinner. There are 5 placemats on the table. Choose an action. Ask, what do I do? What actions do I choose? Count or sort? Let me think. Sorting means to match objects to make sets like this. There is only one set of plates. I know there are 5 placemats, and plates go on top of the placemats. I think counting is a better choice. Choose a prediction. Ask, what is my prediction? What will happen when I count plates? 1 plate on each placemat, or a pile of forks, knives, and spoons? Let me think. The placemat is for 1 person. Each person uses 1 plate. I predict there will be 1 plate on each placemat. Choose a tool. Ask, what do I do? Which tools do I choose? 2 cups and 2 spoons? Or 5 placemats and 10 plates? Say, plates and placemats are in the problem. I choose plates and placemats for my tools. Next, I can choose a strategy. Let me think. How do I solve the problem? What is my strategy? I can count 5 plates to match the number of placemats, or I can count any number of plates. Let me think. When I count 5 plates and put 1 on each placemat, every person has a plate with no plates left over. But when I pick any number, like 3, there are not enough plates. What should I do? Count 5 plates to match the number of placemats, or count any number of plates. Let me think. When I count 5 plates, there's one for each placemat. Every person at the table has a plate. There are no plates left over. But when I pick any number, like 10, there are too many plates. There are 5 plates left over. What do you think? Count 5 plates to match the number of placemats, or count any number of plates. I choose to count 5 plates to match the placemats. Solve by counting 5 plates and placing 1 on each placemat. It looks like 5 is the right amount of plates. 5 plates for 5 placemats. I counted the same number of plates as placemats. Now there are enough plates with no plates left over. This solves the problem better than counting any number of plates. The problems and choices I have showed you are ways for your child to learn about the 5 steps of problem solving. Name the facts of the problem from 2 or 3 choices. Choose an action from 2 or 3 choices. Estimate or predict what might happen from 2 or 3 choices. Choose tools and strategy or a plan from 2 or 3 choices. And use the tools and strategies to solve the problem. Compare the solution to the prediction or estimate. Let's try another problem. There were 4 cans of food in the cupboard. I went to the store and bought 6 more cans of food. How many cans of food do we have now? Identify the facts. Ask, what do I know? What are the facts? I had 4 cans of food. I bought 1 more can of food. Or I bought 6 more cans of food. Let me think. I had 4 cans of food. I bought 6 more cans of food. Choose an action. Ask, what do I do? What action do I choose? Should I add, match, or count? I can add cans of food, match cans of food, or count cans of food. Let me think. Matching means to find objects that are the same. Matching would help me find the same kind of food, but not how many. When I want to know how many, I count. When I want to count 2 sets, I add them by joining the 2 sets. I can count so I know how many there are altogether. So I add and count. Choose an estimate. Ask your child, what is my estimate? What will happen when I add 4 cans and 6 cans of food? Show 2 estimates using food cans, 5 cans and 10 cans. Let me think. 4 cans is almost 5 cans. Then I add 6 more cans. That is more than 5 cans. I estimate 10 cans of food. Take a photo of the choice or draw what the set looks like. Choose a tool. Ask, what do I do? Which tool do I choose? 4 and 6 cans of food, or 1 can and 4 boxes of food. Say, I choose 4 and 6 cans of food for my tools to match the amounts in the problem. I can choose one strategy. Let me think. How do I solve the problem? What is my strategy? 4 plus 6 cans of food to find out how many cans there are, or match cans that look alike. Let me think. When I add 4 cans and 6 cans all together, I can count all the cans to find out how many there are. Matching the cans does not tell me how many cans there are. What should I do? Add 4 cans and 6 cans together and count how many cans there are? Or match the cans? Let me think. When I add 4 cans and 6 cans and count the sets together, I know how many there are altogether. But when I only match the cans, I don't know how many I have, just that some of them match. What do you think? Add 4 cans and 6 cans and count the total number of cans altogether, or match the cans? I choose to add the cans and count the total. Solve by adding 4 and 6 cans, then counting the total. It looks like adding 4 cans and 6 cans, then counting all the cans, tells me how many cans there are altogether. Now I know there are 10 cans. This solves the problem better than just matching the cans. Compare to the estimate. You can make an impact on your child's skills as a problem solver by increasing understanding of how the world works, and you can do it at home with simple chores and fun activities with your child. If you have any questions, ask your child's teacher or contact the curriculum department at curriculum@ablenetinc.com.